Question 1a, solve the following simultaneous equations. So I'm going to break them up into pairs. I'm going to take the first two equations first of all, and I have 3x plus 4y plus z is equal to 1, and I have x minus 5y minus 3z is equal to minus 4. So I'm going to solve for these. I'm going to cancel out the x terms on this question. Again, it's up to you. You can cancel out either variable x, y, or z. I'm going to cancel out the x's. And what do I need to do there? I need to multiply the bottom line by a -3. And when I multiply across by -3, I'm going to keep my top line. So 3x plus 4y plus z is equal to 1. And in my bottom line, I'm now getting -3x plus 15y plus 9z is equal to plus 12. And I can now see that I have a positive 3x and a negative 3x, so they can cancel out. 4y and 15y will become 19y, and z and 9z gives me 10z is equal to 1 plus 12, which is 13. So there's my first equation now found with two variables. I'm going to come over and take two more pairs. So I'm going to take line 2 and 3 this time. And I'm going to go x minus 5y minus 3z. Now with this one, you can see here that there's fractions. So first thing I'm going to do is deal with that fraction. I'm going to multiply across by a common denominator, basically. So I leave myself without fractions. So I have a quarter, a third, and a fifth. They will divide into 12. So I'm going to multiply across by 12. First of all, to get rid of my fractions. So I'm multiplying across by 12. Which is giving me, on the top remains the same, x minus 5y minus 3z is equal to minus 4. And what I could do here, instead of multiplying across just by 12, I'm going to multiply across by minus 12. And that's going to give me minus 3x minus 8y minus 12z is equal to minus 66. So I'm multiplying across by that minus. I'm now going to multiply the top line by a 3, because again, I have to cancel out the x's. So that's going to give me 3x minus 5y, 15y, I should say, minus 9z is equal to minus 12. And I'm going to keep my minus 3x minus 8y minus 12z is equal to minus 66. My 3x minus 3x will cancel out. So that's leaving me with negative 23y minus 21z is equal to minus 78. I now have two equations in terms of two variables, y and z. I'm now going to solve simultaneous equations with two variables now. So I'm just going to scroll down here, write down my two equations again. Equals to 13. And minus 23y. Now very large numbers here, you have to get your common denominators. I'm going to cancel out the z's, and I'm going to basically multiply the 10 and the 21 together to get a common denominator of 210. So I'm going to multiply the top line by a 21 and the bottom line by a 10. And that is giving me on the top 399y plus 210z is equal to 273. On the bottom, I get minus 230, y minus 210, z is equal to minus 780. I now have the y's to be cancelling out, 210z, or sorry, the z's, I mean, 210z minus 210z are cancelling. 399 minus 230 is 169. Y is equal to 273, take 780, which is minus 507. I'm now going to divide across by 169. Let me just scroll down here and make a bit of room. And when I divide across by 169, I'm getting minus 507 divided by 169. So we've got y to be minus 3. Okay, so it comes out fairly nice for us. So y is minus 3. Now I'm going to come over and I'm going to find my z based on that result. So I'm going to find my z. So now find z. and I can take either of these two equations, the 19y, the 23y, or the 399, or the 230. It's up to you. I'm going to take the first one there, 19y plus 10z is equal to 13. I'm going to sub in my value for y and solve for z. And my value for y is minus 3. 19 by minus 3 is minus 57. Plus 10z is equal to 13. I'm going to add 57 to both sides, which is giving me 10z is equal to 70. So dividing across by 10 is giving me z as a value of 7. Okay, so that's a nice whole number there as well. So there's y and z. Final thing I have to do now is solve for x. So I need to take one of my original 3 equations from the top of the question. So I'm just running out of a wee bit of space here. So just go back to the very top of the question, and I'm going to take the very first equation. So now I need to find x I should say. And I'm going to take the first equation, which was 3x plus 4y plus z is equal to 1. I'm going to sub in my values for y and z, which are minus 3 and 7. And when I solve that, I'm going to leave myself with 3x minus 12y plus 7 is equal to 1. So 3x, or sorry, not 12y, I don't have a y there, apologies, let me rub that out. So 3x minus 5 is equal to 1. I add 5 to both sides, so 1 plus 5 is 6. So I'm just going to come up here to keep a bit of space. So 3x is equal to 6, x is equal to 6 divided by 3, x is equal to 2. So there's my 3 values, x as 2, y as minus 3, z as 7. So find the solution set for the following inequality. We're inequalities including fractions. We're going to multiply the left and the right hand side of our inequality sign by the denominator squared. So I'm just going to write down my original question here. It's 2x plus 10 divided by x plus 3, and it's greater than or equal to 1. Now I'm multiplying both sides by the denominator squared, x plus 3 squared. And if I do it to the left, I must do it to the right hand side. And on the left, I can now divide this x plus 3 into one of these x plus 3's, which is basically cancelling out the square. I've now eliminated the fraction, but I'm now going to have to multiply both sides. So I'm going to have to go x plus 3 multiplied by 2x plus 10. And that is greater than or equal to 1 times x plus 3 squared. Well, x plus 3 squared basically just means x plus 3 by x plus 3. I'm just going to separate or expand the bracket, so it's first term by second bracket, and then the second term by the second bracket. And that's the same on the right hand side of the inequality. I'm going to just drop the 1 here because 1 times anything will just be itself. So I'm basically just ignoring the 1 because you think about it, 1 multiplied by x is just x. I'm now just going to multiply in my brackets here, which is giving me 2x squared plus 10x plus 6x plus 30 greater than or equal to x squared plus 3x, 3 by x and 3 by 9 then will give me again plus 3x plus 9. Tidying up left and right hand side, 2x squared plus 16x plus 30 is greater than or equal to x squared plus 6x plus 9. Now we can only solve quadratics when they are greater than or equal to 0. So I'm basically going to move everything to the left hand side here. So 2x squared minus x squared is giving me just 1x squared. 16x minus 6x is 10x. And 30 minus 9 is plus 21. Greater than or equal to 0 now. You can use your minus b formula to solve this quadratic. I'm just going to use the 2 brackets because they look straightforward. To multiply to 21 and add to 10. Well, that's 7 and 3. And they're both positives because the question there, 10 is positive and 21 is positive. I'm now going to solve those factors. So I have x plus 7 greater than or equal to 0. So adding or subtracting 7 from both sides there gives me my x is greater than or equal to minus 7. And I have x plus 3 greater than 0. So x is greater than minus 3. So now let's come and have a look at what that looks like on a graph. So I'm just going to do a quick sketch here of what this quadratic would look like. And it's at minus 3 and minus 7. So they're the solutions where it crosses the x-axis. Now the question does say where it's greater than 0. So that's above the x-axis. So I'm basically looking for the solutions here. That's basically what I need to write down. So what are my answers there? My answers are x less than or equal to minus 7, because again it's going backwards, and it's everything above minus 3. So and x greater than minus 3. Now the reason why we're not putting greater than or equal to minus 3, because the question said x cannot equal to minus 3. And the reason for that is, just take a quick second yourself there to see that if you sub minus 3 in for x, you will have minus 3 plus 3, which is giving you 0, and you can't divide by 0. So just watch there that you have x greater than minus 3. Let's see part C. So solve the following equation. We're going to need our log tables now for this. And in your log tables, it is page 21. And what we're going to do here is, first of all, I'm just going to write down the question. 3 to the power of 2x plus 1 minus 28 times 3 to the power of x plus 9 is equal to 0. So I'm going to first of all focus here on this power, the 2x plus 1. I'm going to rewrite that again from page 21 in my log tables. So that can be written as 3 to the power of 2x times 3 to the power of 1. So that's the first rule there on that page. And then again, that's minus 28 times 3 to the power of x plus 9. I'm now going to focus in on this 2x power. Again, from the log tables, that's the same as me going 3 to the power of x to the power of 2. Again, multiplied by 3 to the power of 1 minus 28 times 3 to the x plus 9 equals 0. Now that 3 to the power of 1, I'm just going to put to the front. So that's the same as going 3 bracket 3 to the x, all to be squared, minus 28, 3 to the x, plus 9 equals 0. Now what I'm focusing in on is this 3 to the power of x. And I'm going to use my u substitution. So I'm going to substitute in u everywhere I have a 3 to the power of x. So therefore, my new equation is going to go 3 times u squared minus 28 times 3 to the power of x, but that's now becoming a u, plus 9 is equal to 0. I'm going to solve this quadratic now. Again, you can use your minus b formula if you wish. And what's that giving me? The factors of 9 will give me 9 by 1. And this will be a minus 1 by a minus 9, gives me a positive 9. And then when I solve that, I get 3u minus 1 is equal to 0. 3u is equal to positive 1. So u is equal to 1/3. And I have u minus 9 is equal to 0. So u is equal to 9 when I add 9 to both sides. Now, I'm not finished because the question doesn't want me to find the value of u. The question wants me to solve for x. So I now need to come back up and write down, well, what is my value of x? Well, I have u is equal to 3 to the power of x. That was from my u substitution. So I'm going to come back up and use that now. And I'm going to do it out twice. I'm going to do u as 1/3 is equal to 3 to the power of x. And I'm also going to do it out for my second value of u, which was 9. So 9 is equal to 3 to the power of x. Now, again, this is all from the log tables, but 1/3 is the same as 3 to the power of minus 1. That's the same thing. And on the right-hand side, 9 is the same as 3 squared. Now, the reason why I'm changing that is I now have them as the same base. See here, I have 3 to the power of something, 3 to the power of something, 3 to the power of something. So I have them all as the same base. So that means I basically just need to compare the powers. So that means that minus 1 is equal to x. So therefore, minus 1 is equal to x. And on the right hand side, I can also have x as a power of 2. So also, therefore, 2 is equal to x. And there are my two solutions for x. Question 2, simplify the following. So we're solving fractions with division, and there's going to be some factorizing going on top and bottom. So let's have a look at the first one here. So I'm focusing in on the 25x squared minus 16. That's just going to be the difference of two squares. So let's rewrite that as 5 squared multiplied by x squared. So that's the same as 5x all to be squared. So put it in a bracket. And the 16 is the same as 4 all to be squared. Let's have a look at the bottom now of that fraction, the denominator. So I'm focusing in on the 3x squared plus 20x minus 7. If we factorize that, I'm going to get the factors of 3x squared, or x by 3x. And the only numbers to multiply to 7 are 7 and 1. So I'm going to have to put the 7 in the right-hand bracket because I need to multiply the 7 by the 3 to get to 21. And that's going to be a positive 7 because that brings me to positive 21, take away 1. So that's my first fraction dealt with. I'm now going to put back in my division sign here. And I'm now going to factorize the second fraction. So let's start with the top. Is there anything I can do to that? Not that I can see. So that stays as 5x plus 4. And now on the bottom. It's looking like it's going to be a quadratic, but I need to factorize out that x squared first of all. So what I'm going to do with this one is I'm going to first of all factorize out something that's common. There's an x squared in all of them, so I can factorize out x squared times 9x squared, because x squared by x squared is x to the power 4, plus 60x, because x by x squared is x cubed, minus 21. That's as much as I can do. I'm going to continue focusing here on this. So let me just rewrite everything I have. Well, actually, let's do this part first. 5x to be squared minus 4 to be squared. As we said, that's our difference of two squares. So that becomes 5x minus 4 times 5x plus 4. Again, the order doesn't matter there. And that is all over 3x minus 1 times x plus 7. And that's divided by 5x plus 4 all over x squared times, now I need to factorize this, and I'm just going to use square brackets here because it's times it all. And what can we do there? Okay, well, actually what I could also do is I could factorize out 3. 3 divides into 9, 3 divides into 60x, and 3 divides into 21. So let me just actually redo that. Not redo it, but I'm going to actually just take an extra step here. I don't want to factorize such large numbers, so I'm going to factorize out 3. So this actually can become 3x squared. And I can multiply that then by 3x squared, because 3x squared by 3x squared gives me 9x to the power 4, plus 20x when I factorize out the 3, and again this will become minus 7. And actually, look what we've just done. We've now found that this, when I factorize 3x squared plus 20x minus 7, it's the same as the one we've already done. So if you've done one of them correct, you'll get the second one. So that's nice and handy for us. So let me just rewrite my question to catch up to that stage. 3x minus 1, x plus 7. And that is now going to be divided by 5x plus 4 all over 3x squared. And the 3x squared plus 20x minus 7 factorizes to 3x minus 1 times x plus 7. Okay, so that's nice. Next thing I'm going to do is deal with this division. In order to divide fractions, we flipped the second fraction and turned it into multiplication. So nothing's happening here with my first fraction. But what I'm going to do is I'm going to turn the division into multiplication. And I'm going to flip the second fraction. And I'm now going to basically hope that a load of things are going to cancel out for me here. So let's see what can cancel from the numerators and denominators. Well, first of all there, I have a 5x plus 4, can cancel with a 5x plus 4 on the bottom. I have a 3x minus 1, cancel with a 3x minus 1. I have an x plus 7, cancelling with an x plus 7 on the top. So basically, what does that leave us? That's leaving me basically with a numerator of 5x minus 4 times 3x squared all over 1, which will be the same as 5x minus 4 times 3x squared. And that's it. I don't think we can, no need to multiply in, because if we multiply in, you'll only end up factorizing again. Question 2b, part 1. Given that we have two factors of a quadratic or cubic equation and you need to solve for a and b. So when I focus in here on, there's different ways of doing this question. I'm going to focus in on the factors that they've given me. And the first factor I'm given is x minus 2. Now, I know that that is a factor, so there must be a solution. So therefore, if I solve this, x is equal to 2 is a solution. I'm then going to take my second factor, 2x minus 1. It has to be a factor, so there must be a solution. So my solution there is 2x is equal to 1. So x is equal to divide across by 2, which is a half. And you know then that if you have solutions, if I sub them in for x, it must equal to 0. They must satisfy the cubic equation. So I'm basically going to do it out twice. I'm going to take my value for x here as equal to 2, and I'm going to substitute it into my cubic equation. So let's just write down our cubic equation here. And I'm going to sub in 2 for x. And it must equal to 0 because it must satisfy. So I'm subbing in 2 and 2 and 2, and that is ax cubed. I'm just missing my cubed there. So 2 cubed is 8, so that's becoming 8a. 2 squared is 4. 2 times b is 2b, plus 6 is equal to 0. That gives me 8a plus 10 plus 2b is equal to 0. And if I add 10 to both sides, or subtract 10 from both sides, I get 8a plus 2b is equal to minus 10. So I've got an equation basically with two variables. I'm now going to come over, do the same thing again, but I'm now going to sub in my second solution for x, which is x is equal to a positive a half. I'm going to take my cubic and sub in x when it is a half. So it's going to be a times something cubed plus something squared plus b times something plus 6, and it must be a solution, so it must equal to 0. I'm subbing in my half. A half cubed is 1/8, so that's giving me an 8a, or a over 8, whatever way you want to write it, plus a half by half is a quarter, a half by b is a half b, or b over 2, plus 6 is equal to 0. Tidying that up, I get 1/8a plus a half b, and that is going to equal to, well, 6 plus a quarter, 6 1/4, which is equal to minus 6 1/4. I now need to get rid of those fractions. So I have an 8, a 2, and a 4. What can we multiply across there by? So we're going to get our common denominator of 8. So I'm going to multiply across here by 8. Just get rid of the fractions now. So an 8 by 8 is 1a. A half by 8 is 4. And 6 1/4 by 8 is 50. And there is my second equation in terms of a and b. Now I'm going to solve using simultaneous equations. So I'm going to take my first equation, which is 8a plus 2b equals minus 10. And my second equation, which is 1a plus 4b equals to minus 50. So using my simultaneous equations here, I'm going to cancel out my b's. So let me just scroll up here and make a little bit more room. So I'm going to multiply the top line by a -2, which is giving me 8a minus 16a, I should say, because I'm multiplying it across by negative 2. So minus 16a minus 4b is equal to minus by minus, which is a plus 20. My bottom line will stay the same as 1a plus 4b is equal to minus 50. Just running out of a little bit of space here. When I solve that, my minus 4b and my plus 4b will cancel out. So I'm just going to move it up here. So that's leaving me with minus 16a plus 1, which is minus 15a. And that is equal to 20 minus 50, which is minus 30. And I'm going to divide both sides by minus 15. So that's giving me a as positive 2. And now I'm going to solve for b. So I'm going to come up here now and find b. And I'm going to take either equation. It doesn't matter which one you take. I'm going to take the first one there. 8a plus 2b equals minus 10. And I'm going to sub in my answer for a. So it's 8 times a plus 2b equals minus 10. And I'm subbing in my a, which is 2. And 2 by 8 is 16. Plus 2b is equal to minus 10. And when I move over my 16 or take 16 from both sides, I get 2b is equal to minus 26. So b is equal to minus 26 over 2 when I divide both sides by 2, which is giving me a negative 13. So my answers there, the question said find the values of a and b. My a is 2 and my b is minus 13. That is going to help us now for part 2 to that question. It says hence or otherwise find the third factor. So what I'm going to do there is, again, there's different ways of doing it. I'm going to do it through long division. So if I substitute in my values for a and b into the cubic equation in the question, so the cubic in the question was ax cubed plus x squared plus bx plus 6. Now I'm going to sub in my a and b, so that gives me 2x cubed plus x squared minus 13x plus 6. Now I know two of the factors, which are 2x minus 1 and x minus 2. In order to get the third one, what I'm going to do is multiply these two factors. That'll give me a quadratic, and then divide the quadratic into the cubic and you'll get the third factor. Now, as you know, there are other ways of doing it, using maybe a new factor and calling it something like maybe ax plus f or something like that, but I think the long division is probably easier. So first thing I'm going to do here is multiply out the two factors that they've given me, and that's giving me 2x squared minus 4x minus x, minus by minus is plus, and tidying that up will give me 2x squared minus 5x plus 2. Now, like I said, to get my third factor, I'm going to divide that quadratic 2x squared minus 5x plus 2 into 2x cubed plus x squared minus 13x plus 6. So a bit of practice of long division here. So 2x squared into 2x cubed is giving me 1x. I multiply back down that 1x, so 1x by 2x squared is giving me a positive 2x cubed. 1x by minus 5x is giving me minus 5x squared, and 1x by 2 is giving me a positive 2. I'm now going to multiply across by minus 1, or in other words, I'm just going to put a change the sign here. And the 2x cubed minus 2x cubed will cancel. X squared plus 5x squared is giving me 6x squared minus 13x minus 2x, I should have an x there, shouldn't I, is giving me minus 15x, and I'm now going to bring down my constant, the plus 6. And I go again, long division again. 2x squared into 6x squared is giving me a plus 3, so I'm bringing that up, which is a plus 3, and now I'm going to multiply back down that 3, and hopefully I get a remainder of 0. So 3 by 2x squared is giving me 6x squared. 3 by minus 5 is minus 15x. And 3 by positive 2 is positive 6. I multiply across by minus 1, so change the signs to a minus, to a plus, to a minus. 6x squared minus 6x squared is 0. minus 15x plus 15x is 0. 6 minus 6 is 0. So I'm basically getting remainder 0. So my third factor, so therefore, third factor is my answer, 1x plus 3. So let's look at question 3. Here we want to prove de Moivre's theorem using proof by induction. First of all, I'm going to list out the steps that's involved in proof by induction. So our steps are going to be that we are going to show it's true when n is equal to 1. Then we are going to assume true when n is equal to k. And then we are going to prove it's true when n is equal to k plus 1. So there's 3 steps involved. Looking at our first step, we are going to deal when it is showing it's true for n is equal to 1. So we want to show true for n equals to 1. Our first natural number, basically. So I'm going to write down what they want me to prove. And our de Moivre's theorem is basically cos theta plus I sine theta to the power of n is the same as cos n theta plus I sine n theta. That's what they want us to prove. All you're basically doing for step 1 is subbing in 1 for n. So on the left hand side, cos theta plus I sine theta to the power of 1 is equal to cos 1 theta plus I sine 1 theta. So that's basically fairly straightforward. We're just basically subbing in 1 for n. Now we are going to assume it's true for n is equal to k. So we're coming down, k is some random number. So we're now on to step 2, which is assuming that it's true for n equals to k. And it's similar enough to step 1. You're basically subbing in k everywhere you have an n. So no difference to step 1. So writing down my formula once again, what they want me to prove, it's cos theta plus I sine theta to the power of n is equal to cos n theta plus I sine n theta. That's what they want me to prove. And when I sub in the value of k, it's going to be cos theta plus I sine theta all to the power of k is equal to cos k theta. So this is what I'm assuming is true, plus I sine k theta. Okay, that's as much as we have to do. I'm assuming that that's true. My third step now is now going to prove that this is true for k plus 1. So the number after k, in other words. So let's have a look and see how that is going to be. So step 3. And we are now looking at prove true for n equals to k plus 1. So what they basically want me to prove is that if I have cos theta plus I sine theta to the power of k plus 1, that is the same as cos k plus 1 theta plus I sine k plus 1 theta. That's basically what they want me to show, that is basically the same thing. Now there I've just subbed it in, but I need to prove that right hand side is true. So basically what I'm going to do now is I'm going to just focus in on the left hand side, the cos theta plus I sine theta to the power of k plus 1, manipulate that and solve it, and hopefully show that it's what I have there on the right hand side. So I'm basically taking this part now, and we are going to do some work to it. Now, first thing I'm going to do there is refer you to page 21 in our log tables. So I'm just saying here, log tables, page 21, and we're going to use some rules there from our log tables to change my powers. So the rules, the first rule there on powers, I can change this now. So cos theta plus I sine theta to the power of k plus 1 is the same as me going cos theta plus I sine theta to the power of k times cos theta plus I sine theta to the power of 1. That's what the log tables on page 21 are telling me. And we have assumed true from step 2 that cos theta plus I sine theta to the power of k is the same as cos k theta plus I sine k theta. Again, we have that from step 2 assumed. And I know then that cos theta plus I sine theta to the power of 1 from step 1 is just cos 1 theta or cos theta plus I sine theta. So I can basically eliminate the power of 1 there. So basically what I've done there is I've used my step 1 and 2. And now what I'm going to do is I'm going to multiply out those two sets of brackets. I'm basically going to do some algebraic multiplication now. So how is that going to look? So I'm going to basically just separate my brackets. So by multiplication now, I'm going to expand my brackets. So it's first term by second bracket. So cos k theta times the second bracket, which is cos theta plus I sine theta. And then the second term, which is I sine k theta times cos theta plus I sine theta. So that's my second bracket. So I'm expanding the brackets there. I'm now going to multiply in. So I'm just using arrows to indicate multiplication. And it'll look a little bit tricky, but trust your algebraic skills now from here on in. So cos k theta by cos theta is becoming cos k theta times cos theta. So I can put a little dot there to indicate multiplication if you want. I'm basically just taking them out of brackets. My second jump, cos k theta by I sine theta, becomes plus cos k theta times I sine theta. So that's my first bracket done. Now coming to my second bracket, I'm looking at the I sine k theta by cos theta, which becomes plus I sine k theta cos theta. Now, it doesn't matter on the order here. It's commutative, so it doesn't matter if you put the cos in front or the sine. It doesn't matter. And my second multiplication there is the I sine k theta multiplied by the I sine theta. First of all there, it has to be a positive. By plus is positive. I by I will give me I squared. And sine k theta by sine theta becomes sine k theta sine theta. Now I'm just going to basically do a little bit of tidying up. But before that, I'm going to deal with this I squared. And we know that I squared is the same as minus 1. So we know that I squared can be changed to minus 1. So I'm basically just going to rewrite this whole line. Cos k theta times cos theta plus cos k theta I sine theta plus I sine k theta cos theta. And now I'm changing the I squared to minus 1. So a plus multiplied by a minus will make this now become a minus sine k theta sine theta. Now you can put in minus 1 if you want, but I'm leaving out the 1. Next thing I'm going to do is just do a little bit of tidying up now. So I'm just basically going to rearrange it. So I'm just going to state here to rearrange. And by rearranging, what I mean here is I'm going to put the real parts to the left and the imaginary parts, anything with an I to the right. That's all I'm doing here. So anything with a real part, so I'm just going to highlight them here. So I've cos k theta cos theta, and I have at the end here I have a minus sine k theta sine theta. So I'm going to put them to the front. So I have cos k theta cos theta minus sine k theta sine theta. I'm now going to deal with the imaginary parts, anything with an I. So I have this plus cos k theta I sine theta. And I have my plus I sine k theta cos theta. So plus I sine k theta cos theta. Okay, so I've just rearranged. Let's see now if there's anything else we can do. I'm going to go now to my log tables once again. So log tables, and this time we're going to page 14. So we're using some rules now on page 14 of our log tables. And what I'm using here now is I'm using the addition of cos a plus b. So hopefully you can see that cos a plus b is this section here. All it's changing here is that I'm now using a k theta and a theta instead of a and b. So in your log tables it's written as cos a cos b minus sine a sine b. And that's basically giving me cos a plus b. Now, as I said, I'm not using a's and b's, I'm using k theta and theta, which is basically going to be rearranged as cos k theta plus theta. That's all I'm doing there. And now I'm coming over and I'm looking at the final two parts here. So I'm going to, again, from page 14 in my log tables, you can hopefully see that they can change to sine a plus b. And again, the reason for that is you can see in the log tables it's written as cos a sine b plus sine a cos b. Now I do have my I there, so basically what you're doing is if you factorize out that I, first of all, it's the same. So let's just write it above here. If I factorize out that I, it's the same as cos k theta sine theta multiplied by I. So I'm just factorizing out that I, and then it would be the same as sine k theta cos theta. So I've just factorized out that I. So in other words, this now will become sine k theta plus theta. And it's multiplied by I. So I'm putting the I at the front or the back. It's up to you. Let's just put it to the back for now. Now I'm going to factorize something out from both of those brackets. Well, I can factorize out the theta. So that's the same as me going cos k plus 1 times theta. Because if you multiply in that theta, you'll get k theta plus theta. And same here with the sine. It's the same as sine k plus 1 times theta I. Again, I can multiply in that theta to get k theta plus plus theta, I should say. We are practically finished. All I have to do now is put them back together. Don't forget that there's an addition sign here between these two that's coming down the middle here. So all I have to do now is add them together. So it's going to be going, so therefore, my final solution here is cos k plus 1 times theta plus, again, from here, my linear expression, sine k plus 1 theta I. Now that's the same as me just putting the I in front of the sine, so that's the same as going cos k plus 1 theta plus I sine k plus 1 theta. And we are practically finished, because if we zoom out here for 1 second, you can now see that basically what we wanted to have in step 3 was to prove that it's equal to cos k plus 1 theta plus I sine k theta, and that's what we basically just have found. And that is the proof to the Moivre's theorem using proof by induction. So part B, given that z is equal to 2 plus 2 root 3i is the complex number, write z in polar form. So in your polar form, we need to get the modulus, which is your or is equal to a squared plus b squared. And then we need to get our angle, our argument, which is tan theta is equal to b over a. and my A is the value in the real part, and the B is the number in front of the I, the imaginary part. So I'm basically going to fill them into my modulus. So or is equal to the square root of A, which is 2 squared, plus B, which is 2 root 3 squared, which is giving me 2 2s are 4 plus 12. So 2 by 2 is 4 and 3 by 4 is 12, which is giving me or is equal to the square root of 16. So my or is 4. I'm now going to come back over to my tan theta. So I'm filling in my A and B. So tan theta is equal to B over A, which is 2 root 3 divided by 2. I'm going to get the tan inverse. So I'm going to have the tan with the little -1 of 2 root 3 over 2. I'm going to go to my calculator now and find the tan inverse of 2 root 3 over 2. And in radians, that's coming out as 1/3 pi, or pi over 3, which is the same if you're working in degrees as 60 degrees. And when I put them together, my form for my polar form is going to be z is equal to or times cos theta plus I sine theta. And that's giving me my polar form as or being 4 cos angle, which is pi over 3, plus I sine theta, which again is pi over 3. Now you can also work to the degrees there of 60 degrees instead of pi over 3. Scrolling down now to part 2 to that part of the question, it's asking us now to use our de Moivre's theorem to find z to the power of 4 in regular form, a plus bi. So let's see what that wants us to do. So let's write down our complex number first of all. So z4 is equal to my complex number, which I have now in polar form from part 1, which is 4 times cos pi over 3 plus I sine pi over 3. And what I'm now doing is I'm putting that to the power of 4. So I'm just going to put this in square brackets just to denote what I want to do. So I'm putting it to the power of 4. And using de Moivre's theorem from my log tables, that is giving me 4. So I put the power, my n to the or, so that's 4 to the power of 4, the power. And I'm now multiplying it by cos n theta, n being the power, which is 4. And I multiply it by my angle. Again, I'm just following the rule of de Moivre's theorem here for my log tables. And then that is plus I sine n theta. Again, my n is the power, which is 4. And my angle pi over 3, or 60 degrees if that's what you're working from part 1. And when I type into my calculator 4 to the power of 4, I'm getting 256. So z to the power of 4 is 256 times cos 4 pi over 3 plus I sine 4 pi over 3. I don't know why I have a 6 written there. Apologies, that should be a 3. And now I just go to my calculator and I type that in. So if I go to my calculator and type in cos 4 pi over 3, I get -1/2. Just make sure now your calculator is set to radians. So it's z to the power of 4 is equal to 256 times -1/2. Again, calculator should be in radians here. Plus I times sine 4 over 3 pi. Again, typing that in my calculator is giving me a -√3 over 2. And don't forget to put back in that I. And if I multiply in that 256 into the bracket, 256 multiplied by -1/2 is giving me -128. So z to the power of 4 is equal to -128. And then 256 multiplied by -√3 over 2 is a -128. And it's been multiplied by I. So -128 √3 I. No need to turn it into a decimal. I think it's best to keep it in surd form. Question 4. Paul and his teammates are doing sprint training in the athletics club. He sets cones 8 meters apart and places a further 23 cones in a line 4 meters apart. So the important bit there is the further 23 cones. Okay, so we need to note that. So there's actually 24 cones altogether. So looking at that first part there, calculate the total distance that Paul will cover in one round of training. So we're basically into patterns and sequences here in question 4. We could do it manually, we could add up all the amount of 4s and back with the original 8, but we're going to use a formula here from our log tables. Just make sure when you're looking at this question, it's asking for the total distance covered. So remember that Paul has to run out to the cone and back. So at the end of part A here, I'm going to be multiplying by 2 because he's running 2 particular lengths each time. So we're looking for the total distance. So we're looking at the sum of the terms. So going to page 22 in our log tables and taking the sum of all terms. So our formula there is Sn is equal to n over 2, n standing for the number of terms, times 2a, a is the first term, plus n minus 1 times d being the difference. So that's the formula on page 22 in our log tables. And when I fill that in, I get the sum of the terms. Now there's 24 terms. Again, remember that he's going to 23 further cones. So there's 24 in total. So it's going to be n, which is 24, divided by 2, bracket 2 times a. A is our first term, which is 8, plus n minus 1, number of terms is 24 minus 1. And the difference then between each cone is a distance of 4, or a difference of 4. And then when we work that out, we get 24 divided by 2, which is 12, multiplied by 16 plus 23 times 4, which is giving me the sum of the first 24 terms to be 108. So 12 times 108, which is giving me 1,296. And remember that we said that he has to go to the cone and back to the start line. So I'm going to multiply that by 2 because he must return each time, which is giving me a distance of 2,592 meters. And that's part A. So part B, it takes Paul 6 seconds to reach the first cone. His time increases by 25% on each subsequent cone. So he's basically getting slower by 25% each time. So his time actually increases. So let's look at the first one. So to get to the first cone, it takes him a flat 6 seconds. To get to the second cone, it's taking him 25% more. So it's basically increasing 6 seconds plus the 25%. So in fact, it's actually taking him 7.5 seconds if I increase 25% onto 6 seconds. But that's the same as me going plus the original 6 seconds multiplied by 1.25. And the 1.25 basically represents the 1 being 100% and the 25 is the 25%. So he's increasing his time there by 25%. Now that's to get to the second cone, but I'm putting that to the power of 1 because the first 6 seconds represents the first cone. So that's the same as 6 multiplied by 1.25 to the power of 0. So just watch the way you've laid out your sequence here. Then to get to the third cone, it's 6 multiplied by 1.25 to the power of 2, and so on and so on and so on until he gets to the last cone. And just watch again the power here. It's 6 multiplied by 1.25 to the power of 23 because our first cone is included in that original 6 seconds. So that's to the power of 0. So 0 to 23 is still the 24 legs in his run. And our next step now, once I've set up my sequence, our geometric sequence, we need to show that it's geometric. So I'm just going to say now show geometric. And to show that it's geometric, I'm going to use our little rule that it's when I divide a term by the previous term, I should get a constant. So if I divide term 2 by term 1, I should get a constant. If I divide term 22 by 21, I should get a constant. So in other words, what I'm doing here is I'm picking any term, so I'm going to call it tn plus 1. And if I divide it by the term in front of it, so tn, I should get a constant. And let's just pick tn plus 1. I'm going to pick maybe 6 times 1.25 to the power of 2. Now you can pick any one of the terms in the sequence. Just take the term then that's before it. So I'm taking this term, and then I'm taking the term before it, so the tn. And if I divide that by 6 times 1.25 to the power of 1, I should get a constant. And let's see, do I do? I get 1.25 when I divide them. So therefore, constant, therefore geometric. Okay, so it doesn't matter which term you pick, as long as you're consistent that your term n plus 1 and your term tn. Okay, and part C, or part B, part 2. So find the total time it takes Paul to complete the course correct to the nearest second. So I'm now coming to my log tables. We found out that it's a geometric series. So I'm using my page 22 in the log tables, the sum of all the terms, but make sure now that you're going for the SN for a geometric sequence and series. You're not going to the sum of terms for an arithmetic series. We're now looking at a geometric. So from page 22, my formula here that I'm going to is the sum of all terms is equal to a multiplied by 1 minus or to the power of n all over 1 minus or. A is the first term and or is the common ratio. Now the common ratio we've basically just found up above in B part 1. It's the constant, the 1.25, what it's increasing by every time. So when I fill in my formula, I'm finding the sum of the first 24 terms, and that is equal to my A, which is my first term from B part 1, which is 6 seconds, the time it took him to get to that first cone. I'm then multiplying it, so I'll just write them out here actually. So my A is equal to my first term, which is 6. My OR is equal to my common ratio. It's going up in 25%, or I'm multiplying by 1.25 each time. Then I'm filling in the remainder of my formula. It's 1 minus or to the power of n. So it's 1 minus 1.25 to the power of n, which is 24 terms. And I am dividing all of that by 1 minus or, 1 minus 1.25. And when I put that into my calculator, the sum of the first 24 is equal to 5,058.197 seconds. And the question wants us correct to the nearest second, so the sum of the first 24 is equal to 5,058 seconds. Okay, that is question 4. So question 5, differentiate 17 minus 4x minus 3x squared using first principles. So when we're looking at our first principles, our derived function, first of all, let's write that down. So we're not differentiating by rule here, it's by first principles. And our derived function will have our limit as h is approaching 0, and it's f of x plus h minus f of x divided by h. So that's the little rule that you need to learn off. And the function that we're given in the question, let's call it f of x. We can call it y or f of x. So I'm calling it f of x is equal to 17 minus 4x minus 3x squared. And I'm now going to do f of x plus h. So that basically just involves a little bit of substitution. So everywhere I have an x, I'm going to sub in x plus h. So that's all that's happening there. And my next step now is going to find what is the value of f of x plus h minus f of x. So that's what I'm going to write down now. So my f of x plus h is 17 minus 4 times x plus h minus 3 times x plus h squared, which is x plus h by x plus h. That's what that means. And what I'm doing now to that is I'm subtracting. So I'm going to put this in a square bracket, and I'm now going to subtract f of x. So I'm on to this stage now, and my f of x, let's just change the color here, is going to be, again, keep it in a separate bracket, 17 minus 4x minus 3x squared. So it's important there to put that in a bracket because of the minus sign, because when we multiply in that minus, it's going to give us a plus when we have minus by minus. So working out this bracket here, we're going to get 17 minus 4 times x, which is 4x, 4 times h, which is minus 4h, minus 3 times, now when I expand these two brackets, we get x squared plus 2hx plus h by h, which is h squared. And then I'm subtracting my f of x, which is 17 minus 4x minus 3x squared. I'm just going to multiply in this 3 now, so that's giving me 17 minus 4x minus 4h minus 3x squared minus 6hx plus 3h squared. So what I'm doing there is I'm multiplying in that negative 3 into the bracket. I'm now coming over to this section here where I'm multiplying in this minus. So we just basically change the signs. Minus multiplied by 17 is minus 17. Minus 1 multiplied by minus 4x is a plus 4x. And minus 1 multiplied by minus 3x squared gives me a plus 3x squared. And that's everything taken out of the bracket. Now you should start seeing things that can cancel out. So this positive 17 can cancel with the negative 17. The minus 4x can cancel with the plus 4x. The minus 3x squared can cancel with the plus 3x squared. So that's basically giving me minus 4h minus 6hx plus 3h squared. I'm coming now to the final part of my derived function from up here. I now have to divide it by h. So I'm coming down now and I'm going to divide by h. So I'm now moving on to the step of f of x plus h minus f of x. So I've done that and I'm now dividing it by h. So in other words, I'm dividing minus 4h minus 6hx plus 3h squared divided by h. And you can see here that h will divide into h and h squared will cancel with the squared. So that's basically leaving me with minus 4 minus 6x plus 3h. And I'm now looking for the limit as it approaches, h is approaching 0. So at this stage now you know that if you get a h in your final solution, you drop anything with a h. So our final answer there is going to be minus 4 minus 6x. So that's our first principles of 17 minus 4x minus 3x squared. Let's have a look now at B part 1. So B part 1 says show that the curve y is equal to 5 over, let's just make a bit of room, 5 over 2 minus x has no turning points and no points of inflection. So there's two parts there basically. In order to show that you've no turning points, that's your first derivative is equal to 0. And then for no turning points, or sorry, no point of inflection, that's when your second derivative is equal to 0. So you basically have two parts. So let's look at the first one here regarding turning points. So for turning points, I'm just going to write down a little rule here. We need dy dx is equal to 0. And my curve is y is equal to 5 over 2 minus x. So I need to differentiate this using our quotient rule. And our quotient rule is dy dx is equal to, from my log tables, v times du dx minus u times dv dx all over v squared. So that is coming from my log tables, and that's what I now need to fill in. So I need to differentiate them. They haven't given us much room here, so I'm just going to do it out to the side. So when I differentiate this, let's call the top part of my fraction u, which is 5, and my v is going to be 2 minus x. And I'm going to differentiate u, calling it du dx, and I'm also going to differentiate v and call it dv dx. So I'm going to now differentiate both of these and see what I get. So with differentiating u, we know the derivative of a constant is 0. So when I differentiate 5, it's just going to become 0. When I differentiate 2 minus x, I get minus 1. And I'm now going to sub them into my formula. So dy dx is equal to v, which is 2 minus x, times my du dx, which is 0, minus u, which is 5, times dv dx, which is minus 1, all over v squared, and v is 2 minus x, all to be squared. Again, don't forget that we want to show that this is equal to 0. When I multiply 2 minus x by 0, that'll become 0. So minus 5 by minus 1 is a positive 5 over 2 minus x, all to be squared, equals to 0. Now, if you want to solve that, you can use cross multiplication very quickly, and you will see that you will get 5 is equal to 0 times 2 minus x squared, which is basically 5 is equal to 0, and 5 cannot equal to 0. So therefore, we are concluding no turning points because we can't get it to equal to 0. Again, just solve that cross multiplication yourself to verify that fact. Coming over now to our point of inflection. Again, we're really stuck for space here, but what you're doing here is your second derivative. You have to show your second derivative is equal to 0. So dyy over dx squared is equal to 0. And I'm now coming down to my first derivative, dy dx, is equal to the answer from part 1 here, which was 5 over 2 minus x, all to be squared. And I'm now going to, again, look, let's save a bit of time here. This is my quotient rule for my log tables, so I'm using that again. I'm now going to write down my u, my v, my du, and my dv. So a little bit of rough work out here to the side. So my u is going to be 5, and I want to differentiate that. So du dx is equal to a constant differentiated, again, gives me 0. My v is equal to 2 minus x, all to be squared. I'm going to just multiply out that. You can use your chain rule if you want, but when I square out that bracket, I get, what do I get there? 2 by 2 is 4, 2x and minus 2x, which is minus 4x, and minus x by minus x gives me a plus x squared. So I'm just squaring out the brackets, and I'm just going to differentiate by rule then, just makes it a little bit easier. So dv dx is equal to minus 4 minus 2x when I differentiate it. Sorry, that's a plus there. Minus by minus gives me a plus, so that's a plus 2x. Now that's the same as, let's factorize out, let's say minus 2. So factorize out minus 2, that's the same as me going 2 minus x. Now look, if you didn't factorize it out, it's fine, but you'll see in a couple of minutes that we might need it factorized out, because I'm seeing, just look at here, see in our previous part, we had a 2 minus x in the bracket. So I'm seeing here that I again have a 2 minus x when I factorize it. So I'm just spotting something there that we might need. Okay, so let's now fill all of that information into our quotient rule. So my dy dx squared is going to equal v times du dx. So my v is going to be 2 minus x, all to be squared, multiplied by my du dx, which is 0. So they'll cancel out and become 0, because 0 multiplied by anything is 0, minus my u, which is 5, times my dv dx, which I have as minus 2, times 2 minus x. Again, if you didn't spot the factorizing, it's fine, you'll get it throughout the question. And that's all over v squared, which is 2 minus x squared, and that is all to be squared. So it's a double square going on there. Multiplying in the 0, as we said, that's going to give me 0. And then I'm going to multiply in now this minus 5, which is going to give me then as a numerator of minus by minus is a plus 10 times 2 minus x. And that is all over 2 minus x squared, all to be squared. Well, using our log tables, rules of powers, the squared becomes a squared. We'll change that to a power of 4. So it's all over 2 minus x to the power of 4. And you can see here now that this 2 minus x on the top will cancel with one of those 4 on the bottom. So that'll give me a power of 3. So that's giving me a final solution of 10 over 2 minus x, all to be cubed. Again, for point of inflection, our second derivative should equal to 0. But again, if I do some basic cross multiplication here, you will see that I get 10 is equal to 0 times 2 minus x, all to be cubed, which is 10 equals 0, and 10 cannot equal to 0. So therefore, no point of inflection. And that is question 5b part 1. Coming down into B part 2, it's only a short little one. John states that the function is always increasing. Is he correct? And explain your answer. Well, John is correct because if you look at the first derivative, so dy dx is always positive. So if the function is always positive, well then it is going to be always increasing. And why is it always positive? Well, if we just examine it here, dy dx, what did we get dy dx to be? We found that dy dx is 5 over 2 minus x all to be squared. And just a little bit of maths common knowledge here. This is a positive number on the numerator, and on the bottom it's also positive. It will always be positive because remember that if I square any number, a square is always going to be positive. So think about it, 2 squared is 4. Minus 2 squared is minus 2 by minus 2, which is positive 4. So if you square any number, it will always be positive. So basically, dy dx here is always going to be a positive divided by a positive, and by your basic rules of number systems, a positive divided by a positive is always giving you a positive. So that's just a basic way of spotting for explaining your answer. Sometimes that explaining the answer part can be a little bit tricky. And that is question 5. So question 6, part A, part 1, integrate each of the following. So first one here we have to integrate is 2x plus 3 all to be squared. First thing I'm going to do is do out my square. So no rule there to help us integrate when we have a power. So I'm going to multiply out very quickly 2x plus 3 by 2x plus 3. And when I multiply that out, I'm going to get 4x squared plus 6x, which is giving me 12x, and 3 by 3 is 9. So that's what I now need to integrate. And when I integrate, I'm using page 26 in my logs. So integrating 4x squared and basically just adding 1 to my power and dividing by my new power on each of the terms. So I increase the power from 1 to 2, divide by 2. Increase the power here. It is 9x to the power of 0, so I increase that to a 1 and divide by 1. Again, you don't need to show that 1, but just for my first step. And I have to put in my constant. We don't know what that is. Tidy it up a wee bit. 4 over 3x cubed can simplify. 2 into 12 will become 6x squared. 1 into 9 will become plus 9x. Don't need to put in the power of 1 plus c. And that's A part 1 done. Coming down now to integrating trigonometric functions. It's asking us now to integrate sine 5 theta, and then we have our limits here, our integrals from pi over 3 to 0. First of all, using our log tables, my little rule here is if I'm integrating sine, I can have a factor in front of that sine, and I can have a multiple in front of the x or the angle. So when I integrate that, I should get then basically a negative cos according to my log tables, and the number in front of the x and the factor in front of the cos remain, but I now divide it by the number that's in front of the x. So that step isn't told in the log tables, but just make sure that you always divide by the number that's in front of the x. So here I need to find the integral of sine 5 theta. Now there's no number in front of the sine, so that's making it a little bit easier for us. But when we integrate sine 5 theta, we are going to get minus cos 5 theta all over 5. So that's our integral. And next step I need to do, I now need to get the integrals using the limits pi over 3 to 0. Basically what you're doing is you're subbing in pi over 3 for theta, and then you're subbing in 5 for theta and subtracting your two answers. So I'm going minus cos 5 times my theta, and my theta in the first case is pi over 3, and I'm dividing that by 5, and then I'm subtracting minus cos 5 times my theta. Again, my theta is 0 in this one, and divided by 5. And I then go to my calculator and work them out. Just make sure that your calculator is set to radians. That's giving me minus 1/10 minus 1/5. So those two minuses will become a plus and it'll become 2/10. So minus 1/10 plus 2/10 is giving me positive 1/10. And that's our answer for part 2. So 6 part A is done. Let's scroll down now and have a look at part B to question 6. The first part is asking us to find points of intersection. Again, points of intersection between a curve and a line. When we have two things intersecting, they must be equal to each other. So all I'm going to do here basically is that since they intersect, I now know that g of x must equal to f of x. That's what we know. So therefore, I can say that 4 minus x is equal to 8 plus 2x minus x squared. So we know that that is the case. And then if I simplify it by either moving things to the left or subtracting 8, subtracting 2x and adding x squared from both sides, that is going to leave me with 4 minus x minus 8 minus 2x plus x squared. And I will have nothing now on the right hand side of that equals. If I tidy it up and put it in order starting with the highest degree, I'd have x squared minus 3x and 4 take away 8 is minus 4 is equal to 0. And I'm just leaving myself then with a basic quadratic equation, which I need to factorize and then solve. And the factors of 4 to get to 3 must be 4 and 1, and it'd be a minus 4 and a plus 1. So what I'm doing there is looking that multiplies to minus 4 and adds to minus 3. And then going to solve that. So I have x minus 4 is equal to 0, and I have x plus 1 is equal to 0. So x is equal to negative 1 and x is equal to positive 4. Don't forget, this question wants us to find the points of intersection. So we've only found x. Now we need to find y. And what I'm going to do is I'm basically going to sub in my values of 4 and minus 1, my x and my y, into g of x and f of x. So let's start off with g of x, which is 4 minus x. And if I sub in g of, so let's say 4 to begin with, I get 4 minus 4, which is 0. Now you can check yourself. Well, let's do it out very quickly. If I do out actually f of 4, hopefully you can spot there that you should get the same answer as 0. So if I sub in 4 into the f function, I should get 0, which I do. So you're just confirming your solutions there basically. So that's one value of y, and I now need to come up and find my second value of y. So I'm basically now going to sub in, I've dealt with the x equals to 4 and I got 0. Now I need to deal with x equals minus 1 and see what I get for that. So now I'm subbing into g of x or f of x, it's up to you, minus 1. And I'm putting in 4 minus 1, which will become a plus. So that's equal to 5. And again, since we have time, let's double check that we are sure that it would be the same if I put minus 1 into f. 8 plus 2 times minus 1 minus minus 1 squared. So use your brackets there and you should see that you get your solution to be 5. That's an 8 plus, multiply by 2 there. I haven't multiplied by 2. So 8 minus 2 is 6, and then take away my 1 is 5. Yes, so it is working. So there I've just checked that my solution for y is 5. So just coming back up to the question, it did say to find the points of intersection, so I'm just going to squeeze it in here. Therefore my points of intersection are x4, y0, x minus 1, y minus 5. And they're my 2 points of intersection. Sorry, why am I putting in a minus 5? It's a positive 5. So our final part to question 6, B part 2. Find the area of the curve, or the enclosed area between the functions g of x and f of x. So we're using this graph up here, and they need us to find or they want us to find this area in here, this area enclosed between the curve. Basically what you're doing is it's similar to 6a part 2. You need to get your integrals, and let's set it up first of all. So we have the area here that they want us to find, that we've highlighted between the curve and the line. So what we basically have to do is get the integral, or integrate the curve, integrate the line, sub in our limits. Now we know that from part B, part 1, that we know that the line and the curve are intersecting at -1 and they intersect at the positive at 4. So they're going to be my limits, basically 4 to -1. And basically now I'm just going to come down and I'm going to integrate both the line and the curve. So there's a little bit of work involved in this one. So my curve is above the line, so I'm starting with that, and it's 8 plus 2x minus x squared. And I'm going to integrate that now in a second, and my limits, as I said, are 4 to -1. From that then I'm going to subtract, again using the limits of 4 to -1, my x values, integrate the line, which is 4 minus x. So when I integrate the curve, integrate 8, I get 8x. Integrate 2x, I get plus 2x squared over 2. And when I integrate minus x squared, I get minus x cubed over 3. And that's it integrated. And I now need to get using the limits of 4 to -1. From that then, I'm going to subtract my line, which is going to be integrating 4 becomes 4x, and integrating minus x becomes minus x squared over 2. And my limits again, 4 is to -1. So I'm going to do both of these out now separately, subbing in 4 and then -1. So I'm first of all going to sub in 4. So it's going to become 8 bracket plus 2 brackets 4 squared minus 4 cubed all over 3 and all over 2. So it's important here that we kind of use brackets because we get to a minus in a couple of minutes and our calculator needs to use brackets. Okay, so that's subbing in the 4. From that, I'm then going to sub in again using my curve when I'm subbing in -1. So from that, I'm subbing in. Now, just to be clear, I'm still on the curve. I'm still doing this part here. I haven't got to the line just yet. So it's going to become 8 bracket plus 2 bracket -1 squared minus -1 cubed over 3 and over 2. And when I sub in -1. So again, as I said, brackets are important here. And with that, I'm going to put them in a large bracket because I need to deal with them separately. So that's the curve done. Now I'm going to come over and I'm going to do the same thing for the line. First of all, though, I need to put back in this equal sign. So I'm going to put minus sign here, and I'm going to subtract. And what are we subtracting? 4x minus x squared over 2. So it's going to become 4 bracket 4 minus x squared, which is 4 squared over 2. I'm going to put them in their own bracket, and I'm subbing in my first limit, which is 4. From that then, I'm subtracting. -4 multiplied by -1 minus -1 squared over 2. Put them in a bracket, and then I'm closing that full bracket because I need to subtract them. So let me just sub in my -1s here. Now, you do know hopefully that you don't have to use your constant here, because if we put a constant in both of those brackets, you would have c minus c, and they will cancel out. So we don't need our constant here. Okay, so working these out, let's see what we get. So on my first one here, so let me just focus on it. I'm doing this part out. So if we go to our calculator and work this section out, I'm getting 80 over 3. I'm then going to my calculator and I'm going to work out this section here. So I need to put back in my minus first of all. And when I work out this portion here, where my limit was -1, I'm getting -20 over 3. And I'm dealing with them again together. So that's the curve dealt with. From that, I'm now subtracting. So I'm going to put this in green so we know that this is this minus coming down each time. The limit of, the line now, so 4 multiplied by 4 minus 4 squared over 2 is giving me 8. And then I have to subtract the 4 multiplied by the minus 1 minus the minus 1 squared over 2, which is giving me minus 9 over 2. And I'm going to put them into its own square bracket. And 80 over 3, the two minuses will become a plus, so that's giving me 100 over 3. Subtract, again, that's this subtraction here. 8 minus minus, which will become a plus, so 8 plus 9 over 2, which is 25 over 2. And 100 over 3 minus 25 over 2 is giving me 125 over 6. And that's my area, so it's square units because we don't know if it's centimeters or meters or whatever it may be in this particular exam question. And that is question 6 done. Just rub these out and we'll move on then to question 7. So we're on now to section B, the context and applications. So question 7 is worth 50 marks. So we have a section of water ducting system used to divert flood water in the shape of a prism. Calculate the internal volume of the duct. So first of all, here we're looking at the cross section of the duct and it's in the shape of a triangle. So we're basically going to get the area of the triangle and then multiply it by the length of the object. So area of a triangle, half the base by the perpendicular height, and then we multiply it by the length for the 3D shape. So if we're looking for the area of the triangle, it's half the base. The base in this case is going to be 5 and my height is going to be 2. We're given that down here, so the height of the duct. And then I'm going to multiply that by the length of the duct, which is 8 meters. So half of 2 is 1, multiplied by 5 is 5, multiplied by 8. So the area of this duct is 40 meters, I think it's in, meters squared. So that's part A, calculate the internal volume of the duct. Now the information there doesn't tell us this in meters, but when we read down into the question around part C and D, it's given in meters cubed and so on. So we're just going to assume for now it's in meters. Part B, write an equation to represent the volume of water in the duct at any time. So they're using T for time, H for height, and W for the width of the duct. So once again, we're using our formula for volume. So the volume of the duct, as we know it now, is half the base by the perpendicular height. And when we fill that in, and we're multiplying it by length once again, and when we fill that in, our general volume is going to be half of the base. Now they call it W, so I'm just going to change the letters here. They call the base W, they call the height H, but we know that the length of the duct is 8. So that is giving me a volume of half of 8, which is 4 WH. And again, I'm going to work to meters squared. So that is the volume of the water in the duct at any time. So in other words, when the width of the water changes, so does the height, and vice versa. So scrolling down now to part C. So use similar triangles show that W can be written as 2.5H. Similar triangles must have the same size angles, but they don't have to have the same length. So that's our congruent. So similar triangles, let's just sketch them out here and see what we have. So I'm going to look at the original shape here, and I'm going to write down the width of 5 and a perpendicular height of 2. That's as much as I know. And then let's look at the general smaller cross section. So I'm going to have a width, not of 5, but I'm going to call it W, and my height is height, basically H. So again, you can refer there to part A and B. You can see that my width and height are taken from 5 and 2. So there are my two triangles that I need to show that are similar. And in order to show them similar, the sides are proportional. So I'm going to match up the 5 corresponds to the W, and that is equal to the 2 on the larger shape corresponding with the H on the smaller shape. And if I cross multiply then, I'll get 5 multiplied by h, which is 5h, is equal to 2 multiplied by w, which is 2w. They want me to show that w is equal to 2.5h. So if I divide across by 2, I get 5h divided by 2. Let me just come up here and we'll write it here. So w is equal to 5h over 2. As a decimal, that's the same as 2.5h. And again, it wants it in meters. So it's telling us now finally that it's in meters. So the width is the same as 2.5h meters. Part D, show that the volume of water in the tank can be expressed as volume equals to 10 times the height squared. So again, we're using our information from part B first of all. So let's write down our volume here. So the volume as we know it so far is 4 multiplied by the width multiplied by the height. So that's taken from part B. And I can expand on that. So I'm going to change my volume now. And that's equal to 4 multiplied by, well, I can change W to 2.5h. So I'm just substituting 2.5h in for W. That's coming from part C, because we know that W is the same as 2.5h. And I'm going to multiply that then by the h. So again, don't forget that there is this h here that I also need to multiply W by. And now I'm going to multiply in 4 by h is 4h, and 4h multiplied by 2.5h is giving me 10 when I multiply 2.5 by 4, and h by h is h squared. So the volume is equal to 10h squared, and that's what they wanted us to show. Scrolling down now to part E. So looking at part E, if water is flowing into the duct at a constant rate of 3 meters cubed per second, at what rate is the height of the water changing when the water has a height of 1.1? So basically this question is talking about rate of change. So the way I have it as our rate of change, if we look at the general case, so say dy dx, when I'm looking for my rate of change, that's the same as dy over my third variable, so dt or dh or whatever it may be, and times then again the same third variable dh or dt over dx. So that's what I have, and I'm working to that. I then come up to this question and see what we have. And what do we know? If the water is flowing into the duct at a constant rate of 3 meters cubed per second, so that's basically the volume changing with respect to time. And that's giving me an answer of 3 meters cubed per second. So as the time goes by, the volume is changing. So that's one thing we know. Another thing that we know is that the volume from part D can be written as 10h squared. Now if we differentiate that, so we find dv dh, that's giving me 20h. So that's as much as I kind of know. If I come over now to my rate of change, let's rejig that. So instead of calling it dy dx, I'm basically asked to find here the volume in the duct with respect to time. So at what rate is the height of the water changing? So the height is changing with respect to time. And if I just change my letters here, instead of calling it dy over d something, it's going to be dh over d something times, again, my unknown over dx, which is my dt. And if I come over now, basically, well, what is my unknown? We are now going to be looking at dt. So this unknown here is now going to be with respect, or sorry, not dt, dv. So you can see here I have a dv and a dv. So we need to incorporate our dv. So this is now going to become dh dt is equal to dh over dv times dv over dt. And I'm just going to now substitute in those values that we have over here in grey on the left hand side. So that's giving me dh dt is equal to dh over dv. Now I just have to manipulate this here. It's dh over dv is what we want, but we have it as dv over dh. So I basically just have to flip my fraction. So this is now going to go dh over dv. So I flipped my fraction. So this is technically over 1. So when I flip it, it becomes 1 over 20h. So I have 1 over 20h times dv dt, which is 3. And again, that's 3 over 1. And when I multiply fractions, top by top, bottom by bottom, which is giving me a final height changing with respect to time as 3 over 20h. Okay, so that is part E. Scrolling down now to part F. So show that the surface area of the water at any time is given by area equals 20 times h. Well, let's have a look at a sketch of the surface area of the duct. So we're looking down into the duct at the surface area of water. We know that the length of that duct is constant. It has to be 8. And the width will change because it's in the shape of that triangle. Now, the width we also know it can be written as 2.5h. So we found that in the previous part to this question. So basically what they want you to do is find the area now of that rectangular shape. And the formula for area of a rectangular shape is length by width. The length of my rectangle here is 8 and my width is 2.5h. And when I multiply 2.5 by 8, I get 20h. And as simple as that. So that's part H. So just a little bit of substitution. Instead of calling it W, we're calling it 2.5h. Coming down now to the final part, part G. It's another rate of change question. At what rate is the surface area of water changing when the water has a height of 1.2 meters? So once again, I'm going to put down my rate of change as I know it. And I have the general case as dy dx, which is equal to dy over the unknown times my d unknown over my dx. Okay, so that's again just our rule for rate of change. I'm just going to list out what I know. So what do we know? So from the part above, so from part F, we know that the area is written as 20h. Okay, so that's what we know. Now, if we differentiate that, we can get area with respect to height as 20. So I've just differentiated 20h there. Let's go a little bit further. From part E now, so I'm just going to come down and write down something else I know. So from part E, we know that dv dt times dh dv is equal to dh dt. So that's what we know from part E. And if I substitute in my values, I have 3 times 1 over 20h. If I just sub in the values for dh dt, and that is giving me dh dt is equal to 3 over 20h. So that's just writing down some of the information that I know so far. So that one is coming from part E. So I'm just scrolling up here to part E. Just remember from part E you got 3 over 20h, but we have to, I don't think I finished out that question, did we? We just had to actually sub in our value then for h, which was 1.1. So apologies, now I'm just going to come back and finish out part 1 here in, part E. And when I sub in my 1.1 for h, I get 3 over 20 times 1.1, which is 0.136 meters per second. So I just needed to finish off part E. So we had it written as 3 over 20h. So I'm just going to scroll back down here now. And that's what we have, yeah, from part E. What else do we know? So I also know that, yeah, actually, let's just fill in our rate of change now. So instead of calling it dy dx, we're calling it dA dt. Okay, so at what rate is the surface area changing with respect to time? So that's A for area, dA dt. And that's going to be, again, just change your letters here. It's going to be dA over d unknown times my unknown over dt. And what is our unknown? So our unknown here is going to be dh, our respect to height, because the question wants when is the water has a height of 1.2 meters. So when I substitute in now dh, it's going to be written as dA over dt is equal to dA over dh times dh over dt. And now I'm just basically going to substitute in everything I know out on the left in grey. So dA over dh I know as 20. And dh over dt I know as 3 over 20h. And again, I multiply top by top, bottom by bottom, which gives me 60 over 20h divided by h. So my common factor there is 20. Now sub in h as 1.2 meters as per the top part of the question. So 3 over 1.2 is equal to 2.5 meters squared per second. So that is question 7. Question 8, part A, write a recurring decimal 1.233 in the form P over Q. Now there should be a dot above that final 3 that it's reoccurring, that it's continuing into infinity. So I need to write 1.23333 and so on as a fraction, basically. How can that number be rewritten? It can be rewritten in units as 1.2 plus, and I'm then going to add on 0.03. So again, test these in your calculator yourself. So 1.2 plus 0.03 is 1.23. And then I'm going to add on another 0.003. So I'm going down into the thousandths. And I'm going to continue that, basically. You can hopefully see that I'm starting a pattern here of adding on tens, hundreds, thousands, 10,000s, and so on. So that pattern is continuing. And basically it's 1.2 plus this pattern. And then I'm going to go to my log tables, and I'm going to my log tables now from page 22. And I'm going to use the sum to infinity to find the sum of all those 0.3, 0.003s, and so on and so on. So I'm using this formula, sum of infinity is a over 1 minus r. Now my a is my first term, and my first term here, just be careful, is 0.03. So I'm leaving out the 1.2. I'm going to add that back in at the end. And my r is my common ratio, what it's going up in. Basically how you find out what it's going up in, take any term in your list. So imagine I take 0.0003 and I divide it by the term that's in front of it, 0.003. So it's basically like, if you want to write it like this, tn plus 1 divided by tn. And when I divide them together, I get 1 over 10. So it's going up in basically the units of 10. And now I'm going to fill in my formula. So I have the sum to infinity is equal to a, which is 0.03, divided by 1 minus r, which is 1 over 10. And when I solve that on my calculator, I get the sum to infinity to be 1/30th. And don't forget now I have to come back and add in this 1.2. So my final answer is going to be, so therefore my solution here is 1.2 plus that sum to infinity, which is now 1 over 30. And when I add 1.2 plus 1 over 30, I'm getting 37 over 30. And again, check your answer, type 37 over 30 on your calculator and hit your SD button, and it should simplify to 1.23 reoccurring with the decimal. So scrolling down now to 8 part B. So they haven't given us a lot of room here, so I'm just going to come over to the side and do it out on a blank sheet. So they basically want us here to derive the mortgage or the loans formula from our log tables. It's basically going to use the use of geometric series once again, so there's a bit of work involved in it. First of all, just to be clear with what all these letters mean, we have our A, we have P, so just let's write down what these letters are meaning. So my A is going to stand for the repayment. My P is standing for the loan amount or mortgage. My I stands for interest rate. And T stands for time. Now that could be years, months, we don't know. This is just deriving the formula. So it tells us that basically, and that's how your typical exam question would look. So what we need to do here is, first of all, we are going to list out a geometric series. So if I was looking at my loan repayments here, so I have the sum of my loans, so I'm going to call that P according to this particular question. And what I'm doing here is I'm setting up my repayment, and that is A, and I'm dividing it by 1 plus I, so 1 plus my interest rate. My next installment is going to be my repayment, A, and it again is divided now by 1 plus I to the power of T. Or not T, sorry, 2 I should say. And we continue that sequence on. So it's now going to be to the power of 1 and then 2. And then I'm going to do repayment, which is A, all over 1 plus I to the power of 3. And so on and so on and so on and so on until my final repayment, which is going to be to the power of T, some unknown year or month. So you can see now that we've basically set up a sequence, and I'm going to use now from my log tables the sum of my finite geometric series. So I'm going to page 22 now in my log tables, and from page 22, as I said, I'm using the formula Sn is equal to A times 1 minus r to the power of n divided by 1 minus r. So this formula is for the sum of a finite geometric series. Finite meaning it ends, basically, it finishes at time t. And now let's just fill in what we know. We know that our A is going to be our first term, which is repayment over 1 plus I. Now I'm just going to call that A for repayment, 1 plus I. And my or is my common ratio, what it's going up in. So basically what you're doing is you're taking any term, so Tn plus 1, and dividing it by the term in front of it. So in other words, if I take like term 3, A over 1 plus I to the power of 3, and I divide that by the term in front of it, which is A over 1 plus I to the power of 2. When I divide them out, I will get 1 over 1 plus I. So in other words, it's going up by a fraction, 1 over 1 plus I. Because in order to get from A to A, you're not doing anything, you're just multiplying it by 1. And to get from 1 plus I to 1 plus I squared, you need to multiply it by 1 plus I. So my value for or here is 1 over 1 plus I, and my value for A is A over 1 plus I. And now we just need to fill in our formula. And there's going to be a little bit of use here of some complicated, I suppose, algebraic manipulation and so on. So let's write down everything we know. So let's fill in our formula here. So the sum of the term, now the sum of the terms is going to be my loan repayment. So I'm now going to change Sn to P. That's the sum of the loan. And I'm going to sub in my A, which is going to be A over 1 plus I. That's my A. And I'm going to use a lot of brackets here. And now I'm going to multiply it by 1 minus my or, which is 1 over 1 plus I, and that is all to the power of t. Again, I'm just filling in exactly as per the formula, then I'm closing that bracket, and I'm dividing all of this by 1 minus or, which is 1 minus 1 over 1 plus I. Okay, so that's our first step. I've basically just filled in my formula. Next thing I'm going to do now is I'm going to try and get rid of this 1 plus I on the bottom. So see here I have on the denominator I have a fraction and I have a 1 plus I in the bottom. So I'm going to try and eliminate that 1 plus I. So what I'm going to do here is I'm going to basically multiply this fraction, top and bottom, by 1 plus I over 1 plus I. So I'm multiplying top by 1 plus I and bottom by 1 plus I. And we know from basic fractions that we can do that because 1 plus I divided by 1 plus I is 1. So I'm basically just multiplying this fraction by 1. That's all I'm doing here, really. And let's set up what that will look like now. So my new loan repayment is going to be payment is equal to, and I'm now going to multiply this by 1 plus I on the top, and it's been multiplied now by a over 1 plus I times my 1 minus 1 over 1 plus I all to the power of t, close my bracket, and on the bottom of my fraction, I'm also multiplying it by 1 plus I, because if I do it to the top, I must do it to the bottom. I have to keep it equivalent, and I'm multiplying that then by 1 minus 1 over 1 plus I. And now I'm just going to multiply in that 1 plus I. So what does that give me now? So on the top, you can see here, hopefully, that this 1 plus I is now going to cancel with this 1 plus I that's over the, or beneath the A. So on the top line, or the numerator, I'm going to have ln is equal to A times 1 minus 1 over 1 plus I to the power of t. So that 1 plus I and the 1 plus I will cancel. On the bottom now, I need to multiply in this 1 plus I into the bracket. So I need to multiply it by both terms. So the 1 plus I multiplied by the 1 is giving me 1 plus I. And then when I multiply the 1 plus I by the 1 over 1 plus I, the 1 plus I in the bottom will cancel with the 1 plus I in the top. So that'll just give me minus 1. Now, just to be clear, just to maybe stop for a second, just make sure that on the top, you only have to multiply the 1 plus I into the first bracket, because it's like, let's say, something simple like this, 2 multiplied by x multiplied by 4. You only need to multiply the 2 into one of the values, whether it's the 2 or the 4. You don't need to multiply it into both of them. So like this here would become 8x. I've multiplied the 2 by the 4 and then multiplied that 8 by the x. That's basically what I did over here on the top of this fraction. I only had to multiply it into one of the terms. Let's see now, can we tidy that up a little bit more? On the bottom of my fraction, I now have 1 plus I minus 1. Well, those 1's will cancel. 1 take away 1 is 0. So I now have ln is equal to a times 1 minus 1 over 1 plus I to the power of t all over my I. And all I'm going to do here now is I'm going to multiply both sides by I. I want to eliminate this fraction, or in other words, basically, I'm cross multiplying. So if you're used to cross multiplying, you put the p over 1 and cross multiply, or multiply both sides by I, basically is what you're doing here. So that becomes pi, or ip, whatever way you want to call it, is equal to 1 multiplied by this, just stays as a times 1 minus 1 over 1 plus I, all to the power of t. So we've got rid of part of our fraction. Next step I'm going to do is I'm going to use my log tables now to deal with this power of t here. So I'm going to page 21 on my log tables, and you can see in your log tables on page 21 that if you have a power to the top and the bottom to a whole fraction, it's the same as putting the power to the top and the bottom. So follow that rule from your log tables here. So pi is now going to be the same as a times 1 minus 1 to the power of t over 1 plus I to the power of t. So that rule is coming there from log tables page 21. And 1 to the power of anything is just 1. So 1 to the power of 5 is 1, 1 to the power of 105 is 1, 1 to the power of t is just 1. So IP, or pi, is equal to a times 1 minus 1 over 1 plus I to the power of t. So we've dealt with our power there. Next thing I want to do now is come back into the bracket, and you can see now that we have 1 minus 1 over 1 plus I to the power of t. So what I want to do here is I want to basically make this 1 a fraction, so I can add or subtract these two together. So I want to basically make these a single fraction. So what I'm doing here basically is it's like I have 1 over 1, and I now need to change that into an equivalent fraction. So our equivalent fraction will be pi is equal to a times, now think about this, 1 over 1 is the same as me writing it as 1 plus I to the power of t over 1 plus I to the power of t. Because remember that 1 plus I to the power of t divided by 1 plus I to the power of t gets me back to 1. And the reason why I'm changing it is that I can now subtract this fraction which has the same denominator of 1 plus I to the power of t. That was the reason for that. And I can now rewrite inside the bracket as a times, and now I can combine these fractions. I can write them as a single fraction, 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. So I've made it a single fraction. Okay, next step now is that I am just going to basically remove this overall bracket. So I'm basically going to just multiply in my a. So this becomes pi is equal to, and I'm just going to basically multiply in the a. I'm not actually going to multiply it in, I'm just removing the bracket. So I can write it as a times 1 plus I to the power of t minus 1 all over 1 plus I to the power of t. And the reason for that now is you can see here that if I put that pi over 1, I can now eliminate that denominator of 1 plus I to the power of t. So what I'm going to do here is I'm going to multiply across by 1 plus I to the power of t. So if I do it to the left hand side, I must do it to the right hand side. Or if you're more used to it, we use our cross multiplication. So that's now going to become pi times 1 plus I to the power of t is equal to a times 1 plus I to the power of t minus 1. Again, maybe just scroll back up to the start of the video and have a look at the formula that we're trying to work to. You can see that we're practically there. We want our formula to be a is equal to. So all I have to do here now in order to get a on its own is divide across by that 1 plus I to the power of t minus 1. So that means that a is equal to pi 1 plus I to the power of t all over, and as I said, we're dividing across by 1 plus I to the power of t minus 1. So we're dividing both sides by that. And again, look at the question at the start. We're very close to it. All we have to do now is factorize out that p. And if it helps, think of an example like this, like 2x over y. That's the same as I can factorize out that 2 to become 2 times x over y. That's the same thing, because 2 over 1, top by top, bottom by bottom, gets me back to 2x over y. So all I'm going to do here is I'm going to factorize out that p. So if I factorize out that p, it becomes p times I times 1 plus I to the power of t all over, but I'm not putting the p as part of the fraction because that's the way they wanted the formula to be written. Minus 1 is equal to a. And if we come back now and look at our formula at the start of the question, that is the way they wanted the question to be written. They've just put it in the alternative order. You can also have it as a is equal to p times I 1 plus I to the power of t over 1 plus I to the power of t minus 1. Okay, so that is the deriving of our formula for the loans and mortgages. Okay, see part 1. John is 30 years old and plans to retire when he is 65 years old. He contributes €700 at the start of each month to a pension fund earning 4% annual equivalent rate, and it'll be a lump sum when he retires. Show that the monthly equivalent rate, so we need to do a little bit of conversion here between rates. We need to find the monthly equivalent rate of an annual rate of 4%. They've given us the answer, but that's what we need to show. So what I do with these questions is we're going to set up our year and I'm going to do my month separate. So I'm given my year, and my year is using just a part of our formula 1 plus I to the power of t. And I'm going to compare that to the month 1 plus I to the power of t. Now a year, my time is going to be to the power of 1, and I'm given the rate, it's 4%, so that'll become 1.04 to the power of 1 to represent a year, and my month will be 1 plus I. Now I don't know what I is, that's what we need to find here, and that's going to be the power of 12 because it's 12 months. Different ways of getting rid of that power of 12. You can use the 12th root or multiply it by the power of 1 over 12. So I'm going to go the root of multiplying it by 1 over 12 because 12 multiplied by 1 over 12 is 1, and I need to do that to both sides because if you do it to the right hand side of the equals, you need to do it to the left hand side of the equals. So I'm multiplying that 1 multiplied by 1 over 12. On the right hand side, like I said, that 1/12 multiplied by 12 will cancel to become just 1. So it's 1 plus I to the power of 1 is equal to 1 plus 1.04 to the power of 1/12, which is 1.00327374. So on the right hand side now, 1 plus I to the power of 1 will just become 1 plus I is equal to this long decimal again. And I want to get the value of I on its own, so I'm going to subtract 1 from both sides or move the 1 over. So that becomes 1.003 minus 1, which is 0.00327374 equals I. Interest rate is to a percentage, so I now need to multiply that by 100. So let me just bring it up here. 0.00327374 times 100 moves my decimal place 2 places, so 0.3274% is equal to I. And that's what they wanted in the question. Moving down then to part 2, we need to use that equivalent rate, I presume, and show that John will receive €632,045 correct to the nearest euro as a lump sum when he retires. Okay, so let's see what's happening here. So he's lodging, what, €700 every month? So let's set up a sequence of payments for John. So he's lodging €700 to an interest rate, so 1 plus I to the power, and what power are we putting here? It's 35 years, and we need to multiply that by 12 months because he's doing it per month, which is 420 installments. And he is saying that he is lodging the money at the start of each month. So yeah, it's 420 installments. So this is going to be my first installment will be in there for 420 months, plus my second last one will be in there for 419 months, and so on and so on and so on until his very last repayment, which will be €700 times 1 plus I to the power of 1, because it's at the start of the month. Let's put in our interest rate now. So this will now become 700, 1.003274. So that's from part 1. I just divided by 100 to turn it into a decimal. 420 plus all of my repayments down to my last one, 1.003274 to the power of 1. And you can see here now that I'm setting up a geometric series. So I'm using my sum of all the terms, which is from my log tables on page 22. And it is a times 1 minus r to the power of n over 1 minus r. So that's the formula that I'm using here now. And the sum of the terms, so first of all, let's write down what I know. My a is the first term, which is 700 times 1.003274 to the power of 420. You can work that out now if you want. I'm just leaving it as it is. And my or is my common ratio. What am I going up in? So again, this is going to be term tn plus 1 divided by tn. So pick any term and divide it by the term in front of it. In other words, what's it going up in? It's going up by a ratio of 1.003274 each time. That's basically what it's going up in. So let's fill in our formula. So the sum of the 420 repayments is going to be a, which is 700 bracket 1.003274 to the power of 420 times 1 minus or is 1.003274. That is to the power of n, which is 420. Close my bracket, and that is all now going to be divided by 1 minus or, which is 1.003274. And if I go to my calculator and I type that in, you should get 63,045 and 24 cents. And the question wanted it to the nearest euro, so that's why at the top of the question it's 63,045 euro. And that is C part 2. Let's scroll down to the next part. So our final part of this question is using a lot of information, types of parts of a question we've already used. So first of all, calculate John invests a lump sum at 3% AER, so annual again. He receives a regular payment at the end of each month. Calculate the value of this payment. So he's receiving it every month. So it's again back to part C. We have to use our equivalent rate. So once again, let's write it out. So it's his year, comparing it to his month. And we're taking 1 plus I to the power of t equals 1 plus I to the power of t. His interest rate for the year is 3%, so that's 1.03 to the power of 1 year is equal to the interest rate that we want to find for a month, which is 12 months. And if we multiply both sides by a 12th, so that becomes 1.03 to the power of 1 over 12 times 1 is equal to 1 plus I to the power of 12 times the 12th. So they're powers, just to be clear. 1.03 to the power of 1/12 becomes 1.0024667 is equal to 1 plus I. And if I subtract 1 from both sides or move that 1 over and take it away, I get 0.0024667 is equal to I. You can multiply that by 100 if you want to turn it into a percentage, and you get 0.24667% for John's interest rate per month. Now he wants to calculate the value of his monthly repayment. So this is like paying back his a loan or such an item. So we're now going to use our derived formula from part B, our mortgage and loans formula. So our formula that we derived was A is equal to P times I multiplied by 1 plus I to the power of t. Again, this is in your log tables, but also from part B, 1 plus I to the power of t minus 1. First thing I'm going to do here is just write down what I know. My A is going to be what we need to find. So A stands for the repayment. P is standing for the loan amount, or of the investment, basically. I obviously is rate, and T is time. So filling in my formula there now, I'm going to have A, which is the repayment, which I need to find. So that's what this question is asking me to find. P is the lump sum that we found in the previous part of this question on C part 2, which was the €632,045. That's my P. I'm now multiplying that into I. So I is my interest rate. So it's this long decimal, 0.0024667. And then multiplying that by 1 plus I, which is 1.0024667. A lot of numbers here, all to the power of t, and it's to the power of 300. So it's 300 months this time, because he wants it after 25 years, and 25 multiplied by 12 is giving John 300 months. And that then is divided by 1 plus I to the power of t, so 1.0024667 to the power of t, which is 300, minus 1. And that's my formula filled in. Trust yourself now, going to your calculator. When we multiply that out, we get a repayment of, well, I'm getting anyway, €2,984. And the question did want to the nearest euro. And that is question 8. So question 9 here, the first part, A part 1, is given the function, find the inverse of the function. So that's our symbol for our inverse. So basically what we're doing, first of all, we have to get rid of the square root. Now we know that a function f of x is another way of just calling y. So I'm just going to call our function y for the time being. So y is equal to the square root of 3x minus 5. And like I said, to get rid of a square root, we square it. So I'm basically squaring both sides. If I do it to the right hand side of the equals, I must do it to the left, and that square will cancel with the square root. So that's leaving me with y squared is equal to 3x minus 5. I'm then going to isolate the 3x on its own. So I'm going to add 5 from both sides, or move over the minus 5, and it'll become a plus 5. And then to get x on its own, I'm going to divide across by 3. So y squared plus 5 over 3. And that's our value for x. Now what we do at this stage is I'm just going to change that x then to our f of x, and basically just changing the symbols, and that's going to be f of x is equal to x squared plus 5 over 3. And I'm going to change that because we know that f of x is equal to the square root. This one then must be my inverse, so it's the inverse of f of x, so f inverse of x. And that's part 1. Is the function f of x bijective, and explain your answer fully. So we'd be saying yes, because by default the inverse exists. So if you want to state the definition of bijective, you can there, but I would say it's just enough to say yes, because the inverse exists. Okay, and if you want, what's our definition of bijective? Our bijective is when we've exactly one element in the domain is mapped to an individual element in the codomain. So if we want to just write that down, it gives a little bit of an explanation to what it is. So exactly one element in your domain is mapped to an individual element in the codomain. Okay, so either of those explanations should be fine there, but because an inverse exists, that means it's going to be bijective, because you have an input and an output there for x and f of x. Part 3, the graph of f of x is shown on the picture here, and it's shown in the domain of 2 to 7. We need to draw the inverse of that function. We know that the inverse of the function from part 1 above, so let's just write it down here to the side, is my inverse, and we got it to be x squared plus 5 over 3. So we have that from part 1 up above. Now we can do a little bit of work here. We can start subbing in our values for 2 to 7. So I'm going to find the values of my inverse when x is 2, when x is 3, and so on. So this is one way of doing it. You can probably draw it yourself, but let's do it out mathematically first. And f of 7. And when I work them out, when I sub 2 in for x, I get 2 to the power of 2 is 4, plus 5 is 9, divided by 3 is 3, isn't it? And if I go through them, when I sub in 3, I get 4. When I sub in 4, I get 7. When I sub in 5, I get 10. When I sub in 3, I get 4.66, so 4 with a little dot. When I sub in 6, I get 13 and 2/3, and when I sub in 7, I get 18. And I'm just going to write down my couples. My couples there would be my input followed by my output. What am I doing? 1, 2. My couple there is 2, 3, so I put in 2 and I got out 3. I put in 3, I got out 4.6. I put in 4, I got out 7. I put in 5, I got out 10. Now you can see on our graph here that we don't have space for our inputs of 6 and 7 and 5. So we might just need to go back a number on our domain here for our inverse. So I'm going to go back, I'm going to find inverse when x is 1, and when I sub in 1, I get an output of 2. So we're going to just see, does that help us now when we're graphing it? Let's graph it now. So if I plot the points, if I plot the point 1, 2, then I'm plotting the point 2, 3. I'm plotting the point 3, 4.6, which is roughly about 3.5, 4, 7. And I can go maybe one more, 5 up to 10. Well, that's going off my graph. So we basically just have those 4 there. And if I connect them again, mine's going to be a little bit rough here, but it's starting to look exactly like the one we already have. I'm then going to draw my line through it. So if you have a ruler here, you're drawing a line through your center. So it's kind of like your y is equal to x. So I'm drawing a line through my origin, and it's going through the corner of each box. So basically you're drawing the graph y is equal to x. So when x is 1, y is 1. When x is 3, y is 3. Again, with a ruler, that looks a lot neater. But that's the line then of x is equal to y. And I have my original function, f of x, here in black. And then in green, I have my inverse function. And that's what they wanted us to do. Draw the graph of the inverse function using the same scale and axis. Okay, so that's 9 part A, 1, 2, and 3 done. Now we're just going to come down and have a look at part B. So part B is they've told us that they've given part of the graph of the function f of x, which is x squared, in the domain. F is to or maps onto real, so or and or. So this is basically our, what would we say? This is our domain here, and this is our codomain. And the first part of the question is asking us to state if this function is injective only, surjective only, or bijective, or none of these. Well, we know that if it is injective, we would carry out our horizontal line test and it would cut the graph exactly once. So you can see here that if I draw a horizontal line, it cuts the graph not exactly once, it cuts it more than once. So it's not going to be injective. So we've eliminated that straight off. Surjective, you know that surjective has to cut through the graph at least once. So we're looking at it here and it could be surjective. It can't be bijective because bijective must be injective and surjective. So we've eliminated injective and bijective. We're also going to state here by looking at the graph that it's not surjective. And the reason why it's not surjective here is that the range doesn't equal the codomain. So what I'm basically putting in, my domain is not going to equal the codomain. So that's the reason why it's not going to be surjective. So we've tested it with our line, our horizontal line, and it does cut it more than once. But by definition, as we said, so my explanation here is going to be that it is none of these options. And my explanation is going to be since the range does not equal the codomain. Okay, so that's a little bit of an explanation there. But you could expand on that by putting down your definitions of your line tests, your horizontal line tests, and so on. And the final part to that question is, by changing the given domain and or the range, under what conditions will the function be bijective? Well, I'm basically going to restrict my codomain. And basically my codomain, what I'm going to restrict it is, I'm going to go for basically x greater than or equal to 0. I'm going to go above my 0. So I have f is the or mapping onto the real or the or, but I'm going to make it just the positives. So I'm only including the positive values there. So that's the restriction that we're making there on part 2, represented from the function f of x equals to x squared. That's part B done. C on that question then wants us to look at writing a quadratic equation using complete the square. So this is the form of complete the square here. And the function that they've given us is 2x squared plus 12x plus 15. First thing I'm going to do there is basically factorize out that 2, because when we're completing the square, it has to be just 1x squared. So I'm going to factorize out that 2 and put it in outside a bracket. And 2 by 1 is 2x squared. 2 by 6 is 12x. Sorry, that's a 15, isn't it? And 2 by 7.5 is 15. So I'm just factorizing out that 2. Next thing I'm going to do is, the rule for completing the square is you take the coefficient of the x, which is 6, you divide it by 2, and then you square that value. And what I'm going to do with that value is then, I'm going to add and subtract it to my my equation now. So I'm going to have 2 bracket x squared plus 6x. I'm now going to add on 9, and I'm also going to subtract 9. Now look, I haven't really done anything to the equation, because I'm adding and subtracting 9 basically means 0. 9 take away 9 is 0. So I'm allowed to do that because all I'm doing there is adding on 0. My next step now is I'm going to factorize the x squared plus 6x plus 9, and then I'm going to put the minus 9 and the 7.5 together. So when I factorize out the x squared 6x plus 9, numbers that multiply to 9 and add to 6 are 3 and 3, and both positive. And the trick there is that you will always get the same two factors. And another way of writing those two factors is as a square. So x plus 3 by x plus 3 is x plus 3 squared minus 1.5. And my final step, just to get it in the way they wanted it in the question, they want us to multiply in this 2. So when I multiply in 2, I get 2 times x plus 3 all to be squared, and 2 multiplied by 1.5 is negative 3. And that's my function, written in complete the square form. The final part to this question, part 2, is hence or otherwise write down the coordinates of the turning point. So our function that we have is y is equal to y is equal to 2 times x plus 3. So this is from the part up above, minus 3. Now our turning points can be found by our standard form for our completing the square, which is y is equal to x minus h squared plus k. And our turning points are going to be the values for h and k. And if we match them up from our equation, our h is going to be negative 3, because we'd have to put in minus 3 there to make a positive 3, because minus minus becomes plus. And that means that k would equal to minus 3 as well, because it is positive k in our standard form. So therefore, my turning point is minus 3 minus 3. And that is question 9 complete. So we're on to our final question, question 10a, and it wants us to find the volume of this open cardboard box. Just some information we know about it. We know that the width of this box is going to be 13 minus the two corners, which are a length of x each. So that's going to be 13 minus 2x. And the width of the box is going to be the full width of 10 minus, again, the two corners of x and x. So that's going to be 10 minus 2x. So you're basically looking at a flat pack box here of a height of x, a width of 13 minus 2x, and multiplied by 10 minus 2x. So they're your dimensions of the box. Looking something like that if we were to sketch it out. Not the best to sketch, but hopefully that makes a little bit of sense as to what we're really looking at here. And if I show now that the internal volume is given by this formula for the volume, so Vx just meaning the volume in terms of x. So we know that the volume of a box is our length multiplied by width multiplied by height. In this particular question, the length of my box is 13 minus 2x. My width is going to be 10 minus 2x. Again, it doesn't matter if you get your length and width mixed up. Multiplication is commutative, so it doesn't matter when we multiply it. First thing I'm going to do is basically multiply in the value of x. Makes it a little bit easier to begin with. So I'll have something like 13 minus 2x multiplied by 10 multiplied by x, which is 10x, minus 2x by x, which is 2x squared. So I'm basically multiplying out these two brackets. So I'm basically expanding my brackets. So first term multiplied by my second bracket. And then my second term from the first bracket multiplied by my second bracket. So I'm multiplying out my brackets here. And what do we get then when we multiply that in? So 13 multiplied by 10x becomes 130x. 13 multiplied by 2 gives me minus 26x squared. 2x multiplied by minus 10x gives me minus 20x squared. And minus by minus gives me a plus. 2 by 2 is 4. X by x squared is x cubed. If we arrange it in order of the highest degree, that is giving me 4x cubed minus 46x squared when I put the x squareds together, and then plus 130x. And that's basically what they wanted. So that's the volume of my box in terms of x. If we scroll down now to part 2 of question 10, it's on the next page. So find the value of x that will maximize the internal volume of the box. First thing we need to look at here is our volume. So let's just write down our volume of our box, which is 4x cubed minus 46x squared plus 130x. Now the key word there is to maximize, and we know when we're looking for the maximum or minimum volume of an object, we need to look at our derivative, and we are solving our derivative when it is equal to 0. So we're basically differentiating the volume of the box, which is giving me 12x squared. 2 46's are 92x, reduce my power by 1, and I get plus 130. And like I said, we solve in order to get the maximum. We let our derivative equal to 0. So I basically just need to solve for x, 12x squared minus 92x plus 130. So I'm going to use my minus b formula, and the reason why I'm not using my two brackets here is because it says give my answer correct to one decimal place. So it's getting a little bit tricky maybe to do it in our head. So I'm going to go x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So I'm using my quadratic formula for my log tables. So x is equal to minus b. My b is going to be minus 92. My a is going to equal the number in front of the x squared, and my c is going to be the constant, which is positive 130. So like I said, x is equal to minus b, and my b is negative 92. So just watch that you have the two negatives in there. Make sure and use brackets here. So b is minus 92, all to be squared, minus 4a times c. And that is now going to be divided by 2 times a, which is 2 times 12. And just to save a bit of time here, when I type that on my calculator, I need to do it for both the plus and the minus. So you're doing it twice in your calculator. So I'm getting x is equal to 5.8 centimeters. And then when I do it out again, I do x is equal to 1.9 centimeters. Now the question, if you look at it, has only one value for x, and I'm going to take the 1.9 centimeters. And the reason for that is if you come back up to the dimensions of your box, and if you think about it, I sub in my value for x here. So let's just scroll up here. If I was to sub in, so imagine I'm over here, my value for x is either 5.8 or 1.9. If I was to sub in the 5.8 for x here, I would have 10 minus 2 times 5.8, which is 10 minus 11 point something or something close to 12, which will give me a negative anyway. And I can't have a negative length on that rectangular box. So that's why my only solution there for x is going to be 1.92. So these are your practical problems. The mathematics has given me two values for x, but I can only accept one of them, and it's the 1.9 centimeters. Okay, part 3 to that question then is asking us if the value of x chosen is to be the integer closest in value to the value that will maximize the volume of the box, calculate the volume of the box. Okay, so look, they're basically just getting us to make sure we understand the phrase of an integer. And our integer basically is a whole number. And we found out that in part 2, we got a value for x to be 1.9 centimeter. The question wants us to use the closest integer value to that. So therefore, my value for x is going to be 2 centimeters. And I'm then going to review my length of the box, the width of the box, and the height of the box. Now, the height of the box is x. These are all coming from part 1 of this question. My width was 10 minus 2x, and my length was 13 minus 2x. So they're coming from part 1, as I said. I'm using the integer 2 for the value of x coming from here. So therefore, the height of the box must be 2. The width of the box is 10 minus 2 times 2, which is 10 minus 4, which is 6. And the length of the box, I'll just do one of them out, is going to be 13 minus 2 times my value for x, which is also 2. So that's going to be 13 minus 4, which is 9. And it wants me then to find the volume of the box. And our formula for volume is equal to length by width by height. So that means volume is going to equal length of 9 width of 6 and height of 2. And when I multiply 2 by 6, I get 12. 12 by 9, I get 108. So the volume of this box that will give me a maximum volume is 108 centimeters cubed. And that's the answer to part 3 done. Hopefully not the worst question there. If we scroll down now to, I think there's one more part to it. It's a part B to this question. So we're moving away now from the box really. So the number of subscribers is given by this formula here, AE to the power of BT. And it's telling us there that A is the number of users, T is the time in months, and they basically want us to find the values of A and B. So let's just write down the formula for number of subscribers. So the number of subscribers at any time is given by AE to the power of BT. And what do we know? It's saying, first of all, at the initial launch, we have 8,500 users. So initial launch is going to be at time 0. So imagine I'm using a stopwatch. At that initial time that I set my stopwatch, it's going to be time 0. So that's why I'm subbing in 0 for time. And at the initial launch, we have 8,500 users. So that's what I know. And I'm just going to basically, instead of calling it N0 is equal to 8,500, I'm going to call it 8,500 users is equal to this formula AE to the power of BT. And we know at the initial time, like I said, when we set our stopwatch or on our calendar, the time there is going to be at time 0. And when I multiply B by 0, I get 0B, which is basically just 0. So that's going to be E to the power of 0. And anything to the power of 0 is 1. So just test that on your calculator yourself. 10 to the power of 1, 11 to the power of 1, E to the power of 1 is all going to be 1. Or sorry, to the power of 0, I should be saying. And A multiplied by 1 is A. So A is therefore equal to 8,500. So that's the value of my A. It then wants us to calculate the value of B. So we've got our A. In order to find the value of B, I'm going to again take the formula. Number of users at a specific time is AE to the power of BT. I can now fill in my A, which is 8,500 users. And it is then to the power of 8,500 times E to the power of BT. And again, we know that N number of users after 4 months is 22,500 users. So that's coming from the question here that at time 4 months, I have 22,500 users. So what I'm going to do there is I'm going to go 22,500 users is equal to 8,500 E times BT. Now my T is going to be time 4. So I'm substituting in 4 months for T. A little bit of algebra here now. To get rid of that 8,500, I'm going to divide across by 8,500. So I'm going 8,000 E to the power of 4B is equal to 22,500, and I'm dividing both sides by 8,500, which is giving me on the left hand side, I'm just going to keep it as 22,500. You can simplify it if you want, is equal to E to the power of 4B. I'm going to use my log tables now on page 21, and I'm going to just change that power. Let me just write in my left hand side, and I'm going to change it now to E to the power of B. So that 4B is commutative. I can write it as just out here, just to be clear, this is the same as E to the power of B4. I can put that 4 after the B, which is the same as E to the power of B in a bracket to the power of 4. So I'm just basically going to rewrite my right hand side as that. And that's all coming from page 21, the top left hand corner of page 21. In order to get rid of that power of 4, I'm basically going to get the 4th root of both sides. Or in other words, I'm going to multiply the power. If you want to use your powers, I'm going to multiply it by the power of a quarter. So if I multiply 4 by a quarter, I get 1. And I think we had a previous question similar to this in our financial maths for our equivalent interest rates. And if you do it to the right hand side, I must also do it to the left hand side. So I'm taking the left hand side and I'm multiplying it to the power of 1 over 4, because that quarter multiplied by 4 becomes 1. So on the right hand side, I have e to the power of b. 4 multiplied by a quarter is 1, so that's b1 or 1b. I'm just eliminating the 1. And on the left hand side, when I work that out in my calculator, I get 1.27553. Now you can keep it as the fraction there if you want. I'm just going to turn it to a decimal. My final step now to get rid of the e, I need to find the power of b. So I'm going to use my log tables. There's different ways of doing this. You can use your natural log if you want. I'm just going to use the rule there on the top right hand corner of page 21, I think it is in our log tables, which says this rule. Okay, so I'm going to use this piece of information here. And let's fill it in. So my a to the x is my e to the b, and my y is my 1.27553. So hopefully you can see that. So I just need to manipulate it into this form here. So that's going to give me the natural log, so log to the base e, which is my a, and I'm multiplying that by y, which is 1.27553, equals my x, which is my power, which is b. So that means when I go to my calculator and type that in, I get 0.24336. The question wants it to 4 decimal places. Sorry, it's just moving on me there on the screen. So if we type that into our calculator and we have to 4 decimals, 0.2434, and that's the value of b. And this question, like I said, wanted us to find the values of a and b, and that's what we've done. So we're now going to come down to the next part to that question, part 2 on page 26, and it now wants us to find if the network continues to grow at this particular rate, how many users will have subscribed after 1 year. So first thing I need to do is basically take my formula now with my a and b filled in. My a was 8,500 times e to the power of b, which was 0.2434t. And I now want to find after 1 year, so time is equal to 1 year. But just remember from the very first part of this question, it said that t is given in months, so 1 year is 12 months. So just be careful there when you're subbing in your t. So I need to find the number after 12 months. So that's 8,500 multiplied by e to the power of 0.2434 multiplied by t, which is now going to be 12. And I go to my calculator and I type that in and I get 157,724 users. We get a decimal point there, but make sure you round it down because we're talking people here basically. So it's 157,724 users. And the final part, part 3 to that question. After how many months will 45,550 people have signed up to the network? So they're basically, again, getting us to use our formula. N to the t is equal to 8,500 times e to the power of bt, which is 0.2434t. Now they want us basically to find after how many months. So they're basically trying to get us to solve for t, and they're giving us the amount of users, and that's what I'm subbing in for nt. That stands for the number of users after a certain time. So I have 45,500. It's very similar actually to, what part is it now? It's very similar to part 1 to this question. You're using your logarithms here to solve for t. So let's just do it out. E to the power of 0.2434t. Let's get rid of that 8,500 first. So I'm going to divide across by 8,500. So that's going to give me 45,550 users divided by 8,500 users is equal to e to the power of 0.2434t. Let's get rid of that 0.2434 first of all. So I can now rewrite this. Again, using my logs here, I'm going to just, using my powers, I'm going to call this e to the power of t to the power of 0.2434. So that's coming from my log tables. And what I'm going to do here is I'm going to again find the reciprocal to get rid of that 0.2434. So I'm going to multiply both sides. So I'm multiplying this power now by 1 over 0.2434. So just to kind of be clear, what I'm doing there is, so this power, let's just bring it out here. What I'm doing is I'm going 0.2434 times 1 over 0.2434. And when I multiply them together, it's like I can put this over 1. It's top by top, bottom by bottom, which will give me 0.2434 over 0.2434, which is equal to 1. So that's why I'm multiplying it there by the reciprocal. Now you don't have to do that out in green, but that's just to show you what's going on there. And if you do it to the right hand side, I must do it to the left hand side. So I now need to come along to the left hand side and multiply all of it by the power of 1 over 0.2434. So when I type the left hand side on my calculator, 45,550 over 8,500 to that power, I'm getting 989.362 is equal to, my powers are cancelling out to become 1, so that's e to the power of t. And our final step is using page 21 rule again for my logs, top right hand corner there. A to the x is equal to y can be rewritten as log the base a, y is equal to x. So that's coming from page 21 in the log tables. And filling it in, my a is going to be e. So I have log e, so the natural log once again. So you can use your ln if you want from your calculator, that's fine. My y is going to be the 989.362 and is equal to x, and x is my power, which is time, which is t. So therefore, t is equal to 6.897 on my calculator. And the question wants it to 1 decimal place. So that means, so therefore, get rid of that 26. So therefore, time is equal to 6.9, I'm stuck for space here, let me just scroll down, 6.9 months. And that is the end of question 10 and the end of paper 1. So hopefully you got through that okay. If you spot any mistakes, let me know. Thank you for watching another tutorial video from Tulla Maths. Make sure and subscribe.